There's a big ass
There's a record button.
We got it.
The red one.
Yeah.
Like
Well,
share screen.
it moved because I'm sharing my screen. Okay, so basically, I'm just gonna kind of walk through all these parts, show you how I did it, trying to make it for examples just a few days ago. I'll show you how I did it when I actually took the exam. So that's a little bit different. I'll show you how Daniel did it. Daniel and I did some pretty similar work. So good job, Daniel, I think. I don't know. Maybe I'm wrong, but I liked a lot of what he had. And then we'll just go through the parts and we can talk about like best practices and stuff like that. So this first part is perhaps a little bit, I don't know, a little bit daunting when you first look at it. It's kind of some weird faceted shapes, but once you actually start modeling it, it's not too difficult to model. So how I did it was started with just this middle block section. I could have done this in half, right down the middle here, because this will eventually, the object I extruded there became the whole middle section, so I could have done half the middle section so I could mirror it later, but really doesn't matter. Just depends on how you want to set up doing the mirror. Again, super simple sketch, literally just a box, so keeping the sketches simple, easy to come back and change any dimensions that you could need. On my second extrude, I added the actual side section. So pretty simple sketch, just this kind of angled section, then the slot in the middle. Could have left the slot for a cut later on, but this sketch is simple enough that it's relatively easy to come back and edit these numbers if you really need to change something about the slot without messing with kind of the actual geometry. And then the final extrude here is just adding that little cutout section to the tip. And yeah, so here's like the first bit of actually useful information. Well, it's not that useful because usually when you're doing a fillet, you have a option between doing a fillet in a sketch or a fillet with a feature. So this is obviously a fillet with a feature, but if I were to go in here, this button up here will do a sketch fillet, and then I can choose two lines that are closer together and add the fillet in there. Generally, in all cases, you pretty much want to do a feature fillet. There are some cases in which you can do a sketch fillet, and we'll get to that with the intermediate part. But this one in particular, it'd be pretty hard to do a fillet in a sketch because you'd have to like do some weird, probably a sweep to get the slot. So in this case, pretty much the only option is to do a feature fillet. So generally, feature fillets you want to go for. And the mirror is not too complicated. I'll look at what I actually did here quickly. So there are some options when you're doing a mirror. First of all, you select the plane that you want to mirror it about. That can either be one of the standard planes that come with when the part opens, or you can actually mirror about any of the planes on your body, or you can create any reference geometry that you want and then mirror around that. So right now, because I have a bunch of features selected, my only options are features to mirror and faces to mirror. Generally, don't worry about doing faces because that's just kind of ends up with weird surfaces. We're not going to get into surfaces for anything we're doing, but features to mirror. So features to mirror, what it does is you just choose any of these features. I mean, it kind of says it in the name. Within the your sidebar over here. And then it will copy exactly that, like over to the other side, as if you just kind of did the same extrude, two extrudes and a fillet on the other side of the thing. So you can do a feature mirror. Also, there's an option for geometry pattern, which kind of makes it more similar to a body mirror. So if I open up a new mirror over here, you'll see that I actually have an option for bodies to mirror. So a body, as opposed to a feature in SolidWorks, come up here to do solid bodies. Obviously, this part is just one body, but hypothetically, you could have multiple body parts. And then I could actually take this whole body and say mirror it around itself over there. And then I could do that. So in this case, I haven't added any more features really at all to the window here. So kind of implicit in this feature mirror is that all the features are copied over even though they don't appear in the timeline. But with this, it actually just copies the geometry of the object itself, doesn't care about any of the features that are made. So this can be useful if, once you get into parts that have like a whole lot of features, like something that could fill up the entire sidebar, it could be a little bit annoying to have to go into the feature mirror and click all of those features and make sure you get the right ones. And then if you move some stuff around, those features are going to change. So what you might want to do is build the part as a body and then mirror the body. So technically what I could do here too is delete this. And then I will very quickly edit this. So now I'm going back to doing just a half piece of this. Fix this extrusion. So now I just have like an actual half of the body. We'll ignore those errors because those aren't going to do anything. So as opposed to doing a feature mirror where I select each of these features and then mirror it over, I can actually just select the whole body and mirror it over itself and get the same kind of thing. Obviously, I've lost some reference geometry in there, but for this one, I'd say feature mirrors are probably preferable, but as you get into stuff with a whole lot of features, it can get a little bit complicated. A body mirror, you can just make your parts as a body and then mirror the body rather than mirroring all the features. And there are options for, like, I can uncheck merge solids. So now I have 2 solid bodies in my part. You'll kind of figure out how to use those as you do it, but get back to how it was. And then finally, obviously to finish this part up with this little groove over here. This time I did it just cutting down from the top, but we'll see kind of as we go in here. This is the part file that I made when doing the actual exam. So here we'll be able to see kind of some differences in how you set up the sketches. So in this one, you can see I have 3 different sketches, well, 4 different sketches if you include the cut, to define the body, and each sketch corresponds to its own feature. And this is generally how you're going to want to set up your parts. So if you have a certain feature, it should have its own specific sketch. You can still reference geometry between sketches by, you can go into the sketch. Let's show this sketch and show this sketch. And then I can come in to edit this sketch. And let's say I want that diagonal line for whatever reason, I can just select it and click convert entities, and then it comes into my new sketch. So generally you always want to have each feature have its own sketch because it just makes it a little bit easier to come back and look through. Because you can see making this part, I did it all with one sketch. Just a single sketch just to keep it, as I was trying to go quick, obviously. So it can be a little bit quicker, but when I come in here, let's say I want to edit some number, like this, like 150 or something. That's a relatively simple edit, but you can kind of see it gets a little bit cluttered. You can lose control of your sketches depending on how complicated the parts are. So generally, you want to not do what I did here. Do as I say, not as I do, and have just a single sketch multiple sketches, one sketch per feature. Just makes it a little bit easier to come back and look through when you're editing the part or checking stuff. It's also good practice for people who, if people are looking at your model that isn't yourself, you'll generally want to have multiple sketches. It makes it a little bit easier for them to understand what's going on too. But again, for relatively simple parts that no one else is really looking at but yourself, you can use a single sketch for everything, just as long as you're not, as long as you know what you're doing, really. Again, use the feature fillet. Obviously, that's the only really choice, but generally, again, feature fillets are going to be your best choice. Tell me if I'm like saying words that you guys don't know what they are. I don't know where you guys are at SolidWorks. I think you guys are mostly experienced, but that kind of stuff. So this is Daniel's part. You can see Daniel pretty much did what I did when I made mine in the CSWA, single sketch to do everything. So again, not technically best practice, but it can work in certain situations. Interestingly, both he and I did a side sketch. I don't know how to explain that. Like a sketch on what is that, the front plane, to define our groove there. I don't really know why I did it. Technically, it doesn't really matter, but just a little bit interesting. In general, I would probably prefer to do a cut from the top as I did here, just because it keeps the dimensions pretty simple. So you just have one dimension on this sketch, and then your other dimension comes from the actual feature. With just a rectangle, it doesn't really matter that much. You can have two dimensions in a single sketch, but you just think about it, try and minimize how much is going on in each of your sketches and each of your features to make it easier to look through as you're going. Okay, any questions about these? Mirrors, general sketch knowledge? Okay, so kind of talk about the intermediate parts. So this one I have a whole bunch of configurations set up to go through the different options that I saw for doing these. Circular parts, so generally with circular parts, revolves are your best option, particularly in this case. So we start with a pretty simple revolve. The geometry in this sketch, you could argue it's a little bit complicated, particularly up here, but doing something like coming in and making, say, just a cylinder or plate kind of thing without any of these features, and then cutting away from that, you're not really going to lose much of the sketch complexity unless you like break, like, say, this cut into one, like this little groove into one, and then this groove into another, and maybe mirror that. But that's probably just going to become more complicated to look at than just having a somewhat more complicated sketch. So we just throw all that around. That's pretty simple. The interesting part, and the part that I want to talk about, is how we do these spokes, or whatever the opposite of a spoke is, I guess. Because there are a couple of ways that you can go about doing it. And it's kind of getting into what we were talking about with the fillets and sketches, and particularly, do you want to do a feature fillet, a feature sketch, or and then with patterns, you can do a feature pattern or a sketch pattern. And so generally, what the rule of thumb is going to be is that, again, you want to use as many feature operations as you can. There can be a bit of a tendency to, when you're making parts, like, oh, I made this in as few features as possible, or as few sketches as possible. And it's definitely fun to do that sometimes, but generally when you're working with parts that other people are going to need to look at and understand, it's perfectly fine to have a super long feature tree for your part, as long as it's making how the part was built make sense. And then it can also help when you're doing other stuff, depending on what the part is for. Sometimes how you build it in CAD can directly correspond to how it's eventually manufactured. So you want to think about all that. Just make it as easy for some rando to look at as the person who spent however long making it. So with this one, this is probably what I would say is the best practice for doing this one, this configuration. So our sketch for our hollowed out spoke area is just uses the geometry of the inside of here and the outside of this ring. So these curves were converted using the convert entity tools from the existing geometry. then just, we know that one is 20 degrees offset from the other. I'm on the wrong side of this, but yeah, so do that, cut, and then what I did was add each of the fillets separately from each other. So I believe like this one and this one are 10, this is like 5, that's like 50 or something. I don't know the exact numbers. But key in here is that each of the fillets is a separate feature. So let's say I know I want to have this small fillet. I can just click that directly and edit that, as opposed to having to go into a sketch and deal with all the other geometry that might be in there. And then for the circular pattern, again, used the actual feature circular pattern. So you could do it in a sketch, pattern this around, and then do all your fillets, or do the fillets in sketch, and I'll show that in a sec. But in general, again, you want to keep your features as, your features list should be as long as you need it to be in your sketches, and yeah, your sketches should be as simple as you can possibly make them. So you notice here, all of these different features are just for this this one configuration, and I have two others that only use these 3 features altogether. So let's go into the sketch fillet. Obviously, it looks exactly the same. It is exactly the same part, but it's made a little differently. So my cut sketch has all of the fillets built into it, which again, depending on the part, can be fine. This part, it is probably fine. You only have 4 fillets in a relatively simple kind of triangular section. But just for best practices, if I wanted to come in and edit this, it's a little bit more annoying to come into the sketch and then having to find the dimension and then having to edit that dimension. It just lead to some issues. And then another issue that you might run into with making your sketches have more complex is that you'll edit something in the sketch, whether that be a fillet or a pattern or something, and then your sketch will break and something will be not defined in the sketch correctly. Some line isn't actually coincident with another one. That happens a lot, where the lines, like visually, they look like they're touching each other, but if you zoom like way in, they're actually like 0.01 millimeters apart, and SolidWorks doesn't like that, and it breaks. Which incidentally, you can use Repair Sketch to do that. That will show you gaps smaller than whatever number you set, and you can know where, if you have particularly complex sketches, that can be a good way to look through them and find where those gaps might be. But again, you just want to keep your sketches as simple as possible. So generally, you would prefer to do it in a feature. And then another thing going on too is the pattern. So an option here is, look, this is just 2 features to actually make this whole part. But if I go into the sketch, you can see quite a lot going on here. All of these are just a circular pattern from this one that we created. There's a lot to look at. Let's say you want to change the number of these spokes. You have to go into the sketch and edit the sketch and do all that. Let's say you want to change the size of the fillets. You have to go into the sketch and edit the sketches, and that just gets annoying after a little bit, particularly if you haven't made the model and you don't know what you're looking for. So just imagine like some random person, they need to be able to look at your model and figure out what is going on as quickly as they possibly can, just to make it a little bit easier for them. And to be clear, there are plenty of people, plenty of engineers who do not do these best practices, and it's very annoying. I've looked at many models that, like, it takes me a long time to figure out what is going on because people have weird sketches, things aren't defined, whatever it is. So, just don't be mean to future people who are going to be looking at your models. It's never particularly fun to have to spend a whole lot of time figuring out what's going on with the model rather than just figuring out what you're trying to do. Maybe I'll show you some of those, but yeah, so essentially what I'm trying to get at here is that you're pretty much always going to have a better designed part. Well, a more rigorous CAD model will pretty much always use more features rather than more complicated sketches. That's just kind of something I want to keep in mind. Daniel, also, to be fair, I have definitely done this. So he did the the fillets within the sketch, and did it that way, which can be fine. But generally, you want to keep the fillets out of your sketches and as much as possible, and use them in features. And then, good job on the circular pattern, just using the feature rather than sketch. The other thing with a sketch pattern is then, depending on what you do after the sketch. So let's say I wanted to, I don't know, add like a very thin rib right in the middle of all of these spokes, so it's not actually like all the way through. And I decided to do that by now extruding from the midplane through this. Then, depending on how you do your sketch pattern, first of all, you might have to like go into each of these spokes and add your little rib or whatever we're going to call it. Or as you edit, like change the number of the things that are going on, number of objects in your pattern, you'll end up with some broken things, and like fillets are a key thing that can break. And say if you use sketch fillets, they're going to break in the sketch, and your sketch is just going to have an error, and you don't really know what's going on. But if you use feature fillets, then the error is going to be right there in the feature tree. It's going to say this fillet is broken, so you can just click it and fix it really quickly, as opposed to having to like look through a sketch and figure out what's going on. Yeah. So yeah, so this is the advanced part. Honestly, I'm not 100% sure about like the ranking scheme of how difficult these parts are, but it is what it is. So I guess in terms of actually how long the feature tree is, this has a lot more features, but I don't know that it's more complicated. So for making this part, it's relatively complex geometry. You got some slots and some weird cutouts here. But really, when you're making any part like this, it's best to just break it down as much as you can, keep your sketches as simple as they can be, make it pretty easy. So you'll notice that this part at the end has a quarter of it cut out. I could have technically modeled the whole thing starting with that in mind, but SolidWorks already has all the tools built in just in their sketches to just make squares and rectangles, because obviously that's what you're going to be making a lot. So it's a little bit easier to go in and just make the model as a square, and then my very final feature is cutting that quarter away. So just start with a box with a hole in the middle. Again, technically, very, very best practice would be to have this hole as a separate feature, but it's a square. I don't know why that dimension is so far out there. Let's ignore that. Having an extra hole in your, or a circle in your sketch is not that big of a deal. And then to get the faceted sides, I did a cut on this one plane here. Again, just a simple triangle, just one dimension to define the whole thing. And then pattern that around. Now, there's an argument to be made here that this is not the most optimal way to do it. Probably one that I agree with, because you see here, by the end of this, there's going to be a fillet on this side. So what I technically could have done is move this fillet up. I can't do it now, but on the fillet here, and then patterned both the cut and the fillet around. And if you have a whole lot of geometry, obviously, I don't want to like give you guys super duper hard parts, so just try and think about having a lot more complexity added to your model. Let's say if there was going to be a fillet and there was going to be like a cut into this face and maybe like some engraved text, I don't know, something. Rather than having to do what I did with the fillet here and click on each individual edge, might be easier to just do the fillet before your pattern. Probably what I should have done, but didn't think about it till just now. But yeah, and then circular inset here, just simple cut, and then mirrored it to the other side. This is probably a fine place to do a mirror because there is no more geometry that's going on with this circle and the corresponding other circle. So it's fine to have the mirror right after the actual feature that makes it, but again, just think about if you're going to have to add more geometry, how am I going to do this later? I had the fillet there. Oh, the feature, sorry, the mirror is a feature mirror again. Kind of difficult to do a body mirror when you're cutting away stuff. So I suppose you could make a body and then mirror the body and then do a cut combine, but that's a little bit much. And yeah, so then this boss extrude kind of gets back to what I was talking about with having the squares be easier. I looked back at the model I did. I'll have it open. I know how to click. So the part I did during the actual workshop, or sorry, the exam, it wants to open. You can see here, I actually did what I'm telling you not to do, and I did a lot of my features after this cut. Sorry, this cut was the one that took the quarter away. And then when I had to do this sketch, something like this, do it with an offset. I assume you guys all know about the offset tool, but when I did this offset line in here, I had to then come in and add 2 more lines at the end here to close this off, so it would actually be a closed feature or a closed sketch. So then I could actually extrude something from it. Just adds a little bit more annoyance to your model as opposed to just adding all of these features while it's still a square, and squares are easy to work with, all that. The slots, pretty simple as far as slots go. So rather than like setting a 45-degree angle or something, you can just draw it to the geometry that already exists. And then pattern that around. Exit my sketch, please. Pattern that around. Again, this is a feature pattern. You can also do a body pattern, like in here. But patterns and mirrors are basically the same thing. Just obviously mirror mirrors it, and pattern you can have a whole bunch of options. Really, you're only going to be doing like linear and circular pattern for the most part. So pattern that, you can do instant spacing, just so technically I could have done this, say, equal spacing 360 and then added 4. And then when I come and cut, we're going to end up with the same geometry, but it doesn't really matter either way you choose to do that. And then another fillet up here. This one probably wouldn't have been a good candidate for circular patterning around, just because it requires the geometry that's created with this extrusion. And this extrusion is already going to be a square. We're not going to make like a quarter, like a kind of pizza slice of this and then pattern that around. That's just going to end up being a little bit weird. Yeah, and then you just cut away what you don't need. Daniel, I think probably you thought that in the drawing that the cutout section was actually just me like showing what's inside, which is fair. Generally, you want to be looking for like hatching in the drawings, and that will actually show you. I don't think I have any parts. I'll pull one up later that actually has some like section views so you can see what's going on. Oh no, I do actually. So yeah, the challenge part, you'll see that a section view where you're looking like at the inside of the body has hatching inside of it, so you can determine that. And usually your like isometric and various views will be anything that's like full shaded and edges or whatever. That's just what the part is actually going to look like. Very rarely have I seen any drawings where the isometric view like that actually shows any more detail or has many dimensions in it, right? So yeah, but otherwise this was a well put together part. Again, you did the right thing by so this sketch, again, sketch fillet in here rather than a feature fillet. I think this one is probably a better candidate for it because, again, since we're patterning it around, the actual, rather than having an extra feature, it's not that annoying to put a fillet in here. And there's only really 2 dimensions in the sketch, so 3 dimensions in the sketch. So yeah, this one was definitely better than like the, say, the first or the intermediate part on the wheel. And yeah, this is a well-designed part. Each feature has its own sketch to go along with it. You start with some pretty basic geometry, literally just a square. And yeah, this was good. So any questions about this relatively normal stuff before we get on to the weird stuff? Okay, so this part was one that I found someone did like a YouTube like CAD challenge or something where there's a bunch of CSWEs or whatever the high level SolidWorks people are. And so it's like a live stream challenge. I don't really know. I didn't really watch it, but this part was one that neither of the competitors were able to figure out how to do in a reasonable amount of time. So, which is kind of funny because it's a pretty simple part. You can see I was able to do it in just 3 features. I was saying earlier, we were trying to figure out a way to do it in less, which the way to do that would probably be a really complex 3D sketch and then a loft. But that would be way more complicated than anything like this. And the drawing that I did for you guys isn't really set up to do that. So I don't know if we want to talk about drawings right now, but this drawing was definitely made with the intention of trying to lead you guys on how to do this part. So if I was gonna draw it as if I wanted the person who was going to be making it to use a loft, I'd probably have to do some section views through it, just so they could see what the geometry is as they go through. I'd have to have like the dimensions of these points in here, dimensions, probably a slice right there just to see what that looks like coming from the top. But so the thing I did here was try and encourage using a revolve, really, is the way that this is intended to be done. The dimension here, the radius of this curved side, this is the kind of fillet looking thing. This isn't actually a fillet. It's actually just a part of a circle, but the radius of this was purposely left out because kind of wanted you guys to get the nuance that the center of this curve lies horizontal with the bottom of the part. So just kind of like something to look at. So it might not seem like it's defined, but having this point up here with the height, this point down here with the height, and the fact that the center of the circle lies along the part is enough to fully define that curve. And what that actually is an ogive, which is what our nose cone is. So when you have, I'll pull up my models of the nose cone in a sec, but an ogive section is essentially just you take a circle and take a small part of the curvature and make a nose cone shape out of it. So technically this is very similar to an ogive, and my first my first operation here is actually making an Ogive. So you can see in here, again, relatively simple. Zoom way out, you can see that this has a horizontal constraint with the actual bottom of the part there. And the next thing that you can do is you just make, so it's a four-sided part. So you can just cut the chamfer and the little facet, I guess, on this side, and cut extrude that out, and then take that and pattern it all the way around. So again, kind of being a dick with this part because it is very challenging, and most like expert SolidWorks people were not able to figure it out. It took me quite some time to figure out that this was how it, I don't know if it's the best way that it should be done, but this is how I figured out how to do it. So I just wanted to see kind of like if you guys were able to do it, and Daniel attempted. He did a decent job. I think what happened here is you got caught on using a loft to do it, and then a lot of your geometry was designed in such a way to try and make it a loft. So I did try and mess around with making it a loft. I could not get it to work with lofts or anything, even multiple ones. Most of it comes down to how this curve is supposed to be set up, because not only is it it looks like a fillet, so you might be kind of tempted, like you did here. Let's see where your sketches. Yeah, so like this, I don't know if this is a circle or a fillet, but this is a circle. But yeah, you kind of might be tempted to like do the geometry with, say, like pointed sides and then fillet that, but not actually what the geometry looks like. And then the loft here, this is where I also ran into a bit of an issue, was trying to get this to actually come to a nice point with that. Lofts are kind of interesting because the nuance in them comes with trying to make sure that all of your profiles have the same number of vertexes. Because when you do a loft from, say, this point to this point, it doesn't just like take the edges and kind of draw between them. It draws one vertex to another. So if I were to say connect this vertex to this vertex, you would get a twisted shape. So particularly when you're doing something like going from a square, which has 4 vertexes obviously, to a whatever this shape is, I don't know, a square with rounded sides that now has 8 vertexes. You have to be really careful about how you do that, so you're not getting twisting, so you're not getting any type of weird geometry. Like sometimes it'll be you'll just tell it to loft something, and it will end up like twisting nearly 360 degrees around. So you get like an infinitesimally small point, as if you're like twisting a rag or something, and then that yells at you a lot, and you have to go in and fix your vertexes and figure that all out. So a loft is definitely probably the logical first thing I would do if I were looking at this part, because generally lofts good for long objects that have like some weird geometry along them. But yeah, in this case, it's a little bit, it's simpler than it seems, and that's kind of where a bit of the fun comes into it. Yeah. So what did I say I was going to talk about? Let me pull this up. Pull up some. Well, do you guys have any questions first of all? You guys try the parts, or I can. Any of you guys want to share your screens? You can, if you did the parts recently, walk through what you did, how it could be better, any of that kind of stuff.
I have a question. Oh, sorry, you go first.
I was just going to show off the part that I tried to do in Creo because I don't have access to SolidWorks. I had a near miss. Let's see.
Let me stop sharing. You should be able to share your screen.
Okay. There we go. So it looks like I got this pretty close when you just look at it from like an isometric view. But if you go to the top, you can see these two lines are on a plane. So I literally made, 4 trajectory planes for my sweep, and then created the lines according to the drawing. So it's close. Like I could sneak it in if I wasn't quite sure how to. I don't know.
Yeah. No, that is. Yeah, sweep is probably, depending on how you do your sweep. I mean, you can sweeps and lofts are sometimes interchangeable, as I'm sure you probably know.
Yeah.
But yeah, and something you could do if this, like, let's say this were the actual geometry I was looking for. This would be a good method to do it. You can just do like I was saying earlier. This might be a really good candidate for doing a pizza slice kind of thing, as opposed to having to do however many planes you had to make in there. Yeah, and then patterning that around.
Yeah.
So yeah, pretty close.
That's all I had to share.
Good shit. Julia?
This might sound like kind of a silly question, but on your sketch for your revolve,
Which part?
on the Ogive,
Mm-hmm.
when I was looking back at the drawing, and I know that you left out that, like, for when you're cutting out, like, the curve on one face, I guess, that, like, you left out the, I guess, like, the radius of
Yeah,
that
I
curve.
just put a question mark here.
Yeah, so for that, like, how did you expect us to, like, get that the correct curve there? You know what I mean? Like, I understand there's there's the initial diameter at the top, the final at the bottom, but then that could still, like, there's some degree of freedom there.
Yeah. Now, so I can just delete this curve and show you what I did. So I can just actually make this arc. So the constraints for any given circle that you're going to run into are usually, or any given arc that you're going to run into are usually like a start and an end point and then a radius. And implicit in that is a direction for how you want it to be. This one, I was kind of just mixing it up. If you were going to do this drawing, first of all, I don't know what purpose this part would have. You can't actually see my screen. Sorry. Here we are. Yeah, so here,
right.
remake the arc. Yeah, so a start and end point, and then usually a radius, which is just like 89 or something, will get me close. But what I was showing in the drawing is that the center point of the circle, or the circle section that you're drawing, is horizontal with the bottom of the part. And that serves as a radius, that constrains the radius of it. Because
I see.
Let's say if I were to move that, if I move this like up and down, which it doesn't want to do because it's so far away, but as I change the radius of this, the center point changes its position and moves kind of along a line like this. And there's only one point where it is horizontal at the bottom.
So you just constrained it to be like parallel, or? Yeah,
you can just like select the origin, and select the point in the origin, and then horizontal.
Horizontal, okay, yeah.
We'll do that.
Okay.
Yeah.
Got it.
And I don't know why that happened. We'll deal with that later. If this part, if you were like making an actual drawing for this part, I don't know if you would necessarily have a radius dimension in here because it is a super weird dimension, 84.5681. Like, you don't really want to have that as a dimension in your document, particularly because if you guys have any experience with documents, you usually set like if it's this many decimal points, it's this tolerance and all that kind of stuff. So what you would probably do is add like a note into it somewhere that says either like an ogive shape if you're in an industry where people might know what that means, or center point coincident with lower section of part or something like that, just to make it, you wouldn't put a question mark and be kind of an asshole about it. But yeah, just to challenge you guys a little bit, see if you guys could figure that one out. I can actually pull up, yeah, let me, see if I can find nose cone from last year. It's getting in my way. Okay, so the nose cone here, some weird stuff going on. That was payload, wasn't it, Mike? Adding stuff to my models. What are you doing?
Wouldn't be surprised.
But yeah, so this is a ogive nose cone. So I would just select either of these, come out, you can see that their center point, also horizontal coincidence with the bottom of that arc. So you'll encounter it, hopefully, a little bit in rocketry, because it is a somewhat common shape. I think like bullets mostly have, or not mostly, but lots of bullets have ogive tips. Rockets, obviously, depending on the rocket, they can have ogive tips. Certainly not the best shape aerodynamically, but it works for most things. Yeah, questions? I can maybe come up with some more parts, put on the screen right now, and you guys can try and do if you want to do that. Let's see. I do try and do either of those parts if we wanted to just do a challenge, or we can end it, or I can talk about something else. SolidWorks doesn't have to be modeling. I don't know. Feel free to unmute yourselves.
Troy, you mentioned documentation and stuff. So how do you know what to like show on your actual documentation? Because how you said the way you wanted to present a part is kind of, or the way you want the next person to like build it is kind of how you present it. How do you know what to choose for what?
As far as drawings? As far as like technical drawings?
Yeah, because you said for the hardest part you had, you showed the inside of it, showed that it was all solid, and then because you didn't want people to loft, you presented it a certain way.
Okay, yeah, so let's look at this. So drawings are a very complex thing. That's probably multiple workshops all in itself, is how to do good drawings, and frankly, they're not my favorite thing to do in the world. But essentially, there are like infinite ways that I could dimension this part and have it be fully dimensioned so that you're able to actually go through and make the part for yourself. Depending on, well, so when you're making a drawing, you just really want to be able to find the easiest way and the simplest way to explain how to make this part. So in this case, if I were to draw this as if it was going to be a loft, let me fix this model real quick because it's yelling at me and I don't know why. We're gonna see how many Control-Z's I have. Enough. Cool. Okay. So if I was going to make this part, let's say I wanted like the only way to draw it, or the way I drew it was a loft. I'd have to do some section views here, and have a section here, and show what that geometry looks like. I'd have to have a section here, and show what this geometry looks like. And it's gone. I don't know where that went. Nope, that's weird. I really don't know why it's yelling at me right now, but I'd have to have a section there. I'd probably want to have a section somewhere along this, the actual curve of it, just to help show that this is in fact not a fillet, but a circular sweep there. Fillets are, I know I've been saying like this is not a fillet or whatever. Generally, fillets are just circles or arcs. Sometimes you can have like different types of fillets, like a G3 fillet is, if you have any Apple devices, they love those. It's just kind of they change the curvature of it as they go through. So fillets are not necessarily always circular arcs, like arc sections or anything like that, just as an aside. But anyway, if I was going to do a loft like this, I would have to have all of those drawings and then annotate those, get all my dimensions, and dimension where the cuts are happening. And then you'd end up with like 3, 4, 5 sketches all the way through this thing, each like cross-sectionally dimensioned. And if the model is created that way, that might be the best way to do it. But generally, at least in this case, that would be super complicated to try and do, even just like actually creating the drawing, let alone trying to figure out how to do the lofts and all that kind of stuff. So when I did this drawing, the key that I wanted you guys to pick up on was that it's a revolved shape. So by having the actual side profile of it and the like section view profile of it have radius dimensions, that's kind of an indicator that there's a radius here. It's a relatively symmetric part. Well, it's perfectly symmetric part all the way around the central axis. So there's probably an application for a revolve in this case. So yeah, like if I was going to do a loft, I would have a whole bunch of section views. If I was trying to encourage a revolve, I would have radius views and views like along the axis that you might be revolving around and all that kind of stuff. So yeah, drawings are nuanced and complicated and annoying and the worst thing you ever have to do in CAD. But you kind of just, I mean, have you guys heard the term design intent? I'm sure I've said it enough. It's like designing the part, a couple ways to do design intent. Designing the part, how it's going to be manufactured, designing the part in such a way that it's like easy to edit. Let's say you're making like one of those blocks with a whole bunch of holes in them. I don't even know what they're for, but that you might see in like people use them as like angle guides for welding stuff together and like bolting stuff to them. Here, let me just make the part. If you're gonna do a block like that, the key thing that you're gonna want to change when you're making that block might be like the number of holes in the block. So what I could do here, so I need a whole bunch of holes in this block. A couple ways I could go about doing that. I can make a circle here, dimension it, however. And then, yeah, so how I did it here, let's say I wanted to then pattern this, and forgive the sketch patterning for a second here, but let's say I wanted to pattern this and make it like that, and like this. And then I wanted to move all of these circles up a little bit closer to the top here. What I've done here is use an angle as my definition for where these circles are located. So let's say I now suddenly want this to be half an inch from the top of this, or this array to start half an inch from the top of the block. And I'd have to come in and like change this angle to whatever the angle would be, or I'd have to delete the angle and add another dimension here that says that this is half an inch. Whereas if I was just making the model and I knew that that might be something that I want to change, I could just get rid of the angle measurement in there and have two dimensions, two linear dimensions. Or let's say I really wanted to be able to, like this was always going to be perfectly along this line here, but I needed to be able to really quickly change like how far it is away. Then having this where it's just one dimension is super simple. So I can make that 20, which doesn't really work. Probably just 2 is fine. Then it's just one dimension to change. Whereas if I had a linear dimension here, as opposed to the angular dimension, then I'd have to change 2 dimensions. So I'd have to have some kind of equal, whatever you call it, relation between them. And yeah, so it's just kind of thinking ahead on what kind of parts you're making, how you want them to be made, how you want them to be edited in the future, all that kind of stuff. And it's, yeah, it's an art, I'd say. It's not, you're not going to be able to listen to me and suddenly know exactly how to design every part you're ever going to have to design. You're not going to be able to read a book and know exactly how to design every part you're going to design. It's just kind of, you pick up things as you work with it. Won't take that long before you realize that you're better than you think you were. I'm inspiring, I'm good at speeches. But yeah, that's kind of design intent in a nutshell. And yeah, drawings, sorry, I kind of got caught up drawings. Drawings are a mess. Any other questions? Parts you want to do, you want to try?
I actually got to head out. It's 3, but thanks for the lesson, Troy. And I will see you guys when I see you.
It's Minnesota time, imagine.
Oh yeah, for
Couldn't
sure.
be me. See you, Mike.
See you.
Okay, well.
Wait,
any more you guys want to do?
I have a question. First off, for the rocket modeling parts, do you have them on the drive or something so I can check them out? Or
the parts we made for the Spaceries rocket?
Yes.
Yes, they're on the GrabCAD. Are you on the GrabCAD?
Is that? Yeah, I am. It's the drive, right?
Okay.
Oh,
not the drive.
Oh, GrabCAD.
GrabCAD.
I don't know what that is. No, I'm not on that thing.
He joined late, Troy, so he didn't get
Okay. Oh God,
he didn't start when we were designing anything.
Right.
Let me add you in that case. Oh,
I'm supposed to make an account.
Yeah, I'll just send you an email.
Okay. Yeah.
What's your WPI email?
D. Santa Maria.
I'm definitely gonna spell this wrong.
Okay.
I'm awful with this. I'm just gonna look it up. Sorry, I'm sharing my screen to everyone. I'd love to see that. Oh God, do you guys also have to do the double authentication or whatever
Yeah, I want to change that. Can you or no?
I would
you
say
have to
hate
do
that.
You guys talking about?
Like when they text
Two-factor.
you.
Yep.
Yeah, bro. I was literally working on that for like 20 minutes trying to figure out how to like just stay
Usually
logged
you can
in.
make it
don't-
Like,
remember
why
a
is it so
device.
hard?
Yeah, I don't think you can.
Troy, do you want to start recording unless you're not talking about other CAD stuff?
Are you telling me people don't want to listen to my ramblings on multi-factor authentication?
I mean, sure, if they really
Sure.
want to, we can do it. We'd have to change the name
This
of
has
the
turned
workshop.
into Troy's